Hello and welcome. This is Bijan Hushiar. This internet network is configured as dual stack. All the devices have both IPv4 and IPv6 addresses. The purpose of this video is to use TCP/IP and SHOW commands to test connectivity, to learn how to troubleshoot and discover neighbors. First, we do some TCP/IP commands by going to command line interface of PC3, and we perform IP config /o. This command will display the physical address or MAC address of the Ethernet interface of the PC3 that is being used to connect to the network. Both its IPv6 and IPv4 addresses, subnet mask, default gateway for both IPv4 and IPv6 of the PC. Optionally, we could use IPv6 config /o. This one will only display the IPv6 addressing of the PC in addition to its physical or MAC address. It doesn't display the IPv4 addressing of the PC. So that's the first command that we perform to obtain information about our own PC when we want to troubleshoot. Next is testing end-to-end connectivity. We want to see if PC3 with this IPv4 address and this IPv6 address is capable of reaching devices in the remote network where PC4 and server are residing with IPv4 addresses and IPv6 addresses as shown on diagram. So we go to the command prompt of PC3 and we perform ping 192.168.2.2, which is the IPv4 address of the server in that remote network. If replies are coming back, there is end-to-end connectivity. If we receive destination host unreachable, then there is a routing issue. The replies are coming back. 4 echoes sent, 3 replies came back. Even if 1 reply comes back, it means there is end-to-end connectivity. Normally, 1 or 2 of those replies may be lost when we perform the first ping command. All 4 replies are coming back. There is end-to-end connectivity as far as IPv4 addressing is concerned. But let's test IPv6 connectivity. Ping 2001:db2:2, which is IPv6 address of server in that remote network. Press enter. If replies are coming back, there is also end-to-end connectivity as far as IPv6 is concerned. If destination host unreachable is received as a reply for the echo replies, it means that there is a routing issue. Now that we have been able to ping those remote hosts, let's perform another command, arp-a. This one will display the ARP cache table of the PC3 for IPv4. IPv6 is not broadcast based, ARP is not working on it. So this one tells us that Uh, this IPv4 address has this MAC address. In other words, PC3 has resolved this MAC address to this IPv4 address. This IPv4 address is IPv4 address of the G00 or default gateway of the PC3, and the MAC address is the MAC address of that interface. Let's take a look at it one more time. IPv4 address of G00 of router 1 and its MAC address. Why did the PC resolve that MAC address to that IPv4 address while we reached this remote network? Because ARP is broadcast based and routers do not allow broadcast to go from one side to the other side. Whenever there is an ARP request for a remote device, routers will return their own default gateway's MAC address to hosts such as PC3 and PC5. Let's see if PC3 can ping PC5. Let's go to command line interface and perform ping 192.168.1.5, which is the IPv4 address of PC5. Yes, it can. Now let's examine the ARP cache table of it. You'll notice that there are two entries right now. One for PC5 with this IP address and that MAC address, they are resolved to each other, and the other one for IPv4 address of the default gateway of PC3 and the MAC address of the default gateway interface. How do I know this is the default gateway of PC3? You guessed it, IP config /all will display that default gateway information to us. Since we are using IPv4 addressing right now, and ARP only works with IPv4 addressing, this IPv4 address is going to be used as the default gateway of the PC3 and PC5. Now, let's perform another command, netstat space -r. This command displays the routing table of the PC3. It says that to reach any destination network with any subnet mask, this is the default gateway for PC3, and PC3's IPv4 address is this one, and default gateway of it is this one. This is sort of like a routing table of the PC3. I have already configured telnet on router 1 and router 2 and switch 2. Let's go ahead and see if PC3 can telnet to those two devices. We go to the command line interface again, and we perform this command, telnet space the IPv4 address of the destination device that we want to telnet to it. For the switch, it is 192.168.2.253 for switch 2. After we press enter, we are going to be prompted for the password. When we type the password, we cannot see it, and then we press enter. I'm accessing switch 2 right now. I can start configuring switch 2 from PC3. But let's go ahead and exit because I want to show you another command. Let me go ahead and perform a netstat command without -r. If I do that, you'll notice that it says TCP protocol was used by this source host, which is PC3, with this random source port address to reach the foreign host with this IPv4 address, which is the IPv4 address of VLAN 1 of switch 2, and this port destination port number was used 23 for telnet. So netstat displays that information. In real life, if you do this command, it will also provide information if you connect to an HTTP server or any other foreign host outside your network. The combination of the IPv4 address and port number is called socket. The source port address is always a random number. Destination port address is specific to the application that we use. 23 is set aside for telnet. We have performed ping ipconfig /all IPv6 config /all arg -a to display the cache table of the PC. We have performed netstat to display the information for active connection to foreign host, and also netstat with -r to display the routing table of the PC. So these are some of the TCP/IP commands that are useful for troubleshooting. Another one is Tracert. Tracert is going to trace packets sent from a source PC such as PC3 to a destination device such as this server. If we take a look at this diagram, there is 1, 2, 3 hops from PC3 to get to server. In real life, we don't see this part of the internet network. Tracert is going to tell us how many hops exist between source and destination. Let's go ahead and perform that. The command is Tracert space 192.168.2.2, which is the IPv4 address of a server in the remote location. As you can see, it shows successful connection, and there are 3 hops. The first hop will go to the default gateway of PC3, router 1. Second hop gets to the serial 001 of the router 2. The third hop will get the packet to the destination that we intended to reach, which is the server. Tracert and ARP have their own counterparts as far as Cisco devices are concerned. Let's access the command line interface of the router 1. Enabled from user mode. By typing enable, I go to privilege mode, and I can ping devices such as that server ping 192.168.2.2. As you notice, communication was successful. Success rate was 100%. I can trace packets to that destination. How many hops do you think from router exist to reach that server? 1, 2 hops. Let's see if the command that we perform is going to verify that. The command for the router that is the same as Tracert for PCs is Traceroute. Traceroute space destination IPv4 IPv6 address 192.168.2.2. There should be 2 hops to reach that destination. One will go to the from router 1 to the serial 001 of router 2. The second hop is from router 2 to destination that we intended to reach. So ping is the same on router as PCs. Tracert on PCs can be used to trace packets. The counterpart for that is Traceroute on routers, Cisco routers. We performed ARP space -A to display the ARP cache table of the PC. On the router, we have to perform a show command. Show space ARP. It displays that it has already resolved this IP before address, which is the IP before address of PC3 to its MAC address table. It has also resolved the default gateway MAC address, which is its own serial, which is its own G00 interface to this MAC address. It didn't resolve MAC address of the serial interfaces to any IP address. The reason is that serial interfaces do not have MAC addresses. Now, on PCs, we used netstat with -R to display the routing table of the PC. The counterpart for that in a router is show IP route. This will display the IPv4 routing table of the router. There should be two connected networks and something related to routing protocol to reach remote networks. Let's press enter. As you notice, there is one for connected network to G00 of it. L is the exact IP address of that G00. There is another connected one for serial 00 of it, and there is one designated as S*, which is a default static route that I have configured on this router, meaning if you want to reach any remote network, if you receive a packet from any remote network, send it out of that serial interface, because let's face it, every other remote network to router 1 is reachable if the packet is sent out of serial 00. Routers have more than one routing table. They have one for IPv4 and one for IPv6. If we want to display the IPv6 routing table of the router, the command is show IPv6 route. It will display that yes, there is a default static route to reach any remote network. There is one connected network to G00, another connected network with the different prefix connected to serial 00 of it. Now, one more command that is helpful in troubleshooting, sometimes you have problem on your router, is to perform show IP interface brief. This will display all the interfaces that the router has if they have been assigned an IP address, IPv4 address, and if they are up. Okay. If you want to display such information for IPv6 addressing that you have configured on the router, the command is show IPv6 interface brief. I have abbreviated interface with int. It works. Press enter. It will display all the interfaces G00 with this linked local address, with this globally unique IPv6 address. G01 and G02 do not have any IPv6 addresses. Serial 00 of it has this linked local address, this globally unique IPv6 address. Notice that link local address on both interfaces are the same. It's okay. Link local address, as the name implies, it's a link significant. So you can assign the same link local address here and there. You cannot assign the same link local address here and here. It wouldn't work. It will be duplicate. Because this is one network, all link local addresses must be unique. This is another network. The same link local addresses that we're using here can be used in here. It's not the same for globally unique IPv6 addresses. They have to be unique in both networks. Link local address can be repeated. Now we want to turn our attention to a protocol called CDP, Cisco Discovery Protocol, which by default is enabled on Cisco devices. It discovers the neighboring devices to the device that you are on and it displays information about it. It's a very powerful tool for troubleshooting. However, since it exchanges information that is related to the configuration of our devices, it can be a security risk if you keep it running all the time. You need to turn it on and use it, and turn it off when you do not need to use it. But remember, by default, it is turned on globally. So let's go to command line interface of router 1 and see if CDP is enabled. We go to privilege mode by typing enable, and then we perform show CDP. CDP is enabled. By default, it is enabled globally. By default, it is enabled on all interfaces. If you want to turn it off globally, you have to go to global configuration mode and perform this command, no CDP run. You turn it off. If you go back to the privilege mode and perform show CDP, you'll notice that it says CDP is not enabled, but we want to enable it for this activity to show you how it works. So I go back to global configuration mode and enable it, CDP run. CDP is enabled right now. I go to one of the interfaces of this router, interface G00, and then in here, by default, CDP is enabled. You can disable it on an interface also. The command is enable or no CDP enabled. No CDP enabled. It's going to turn it off on that interface. No information will come to this router 1, through the G00 interface since I turned it off. But I want to turn it on because I want to show you how CDP works. So I enable it on the interface by this command, CDP enabled. Now, CDP is enabled globally and all interfaces of the router. Let me perform some show commands. Show CDP. Just first show CDP to see if it is enabled. It is enabled, and then show CDP neighbors. It's going to display information about neighboring devices to router 1. Press enter. As you notice that it says there are 2 devices that are neighbored to router 1. One is called S1. It is connected to G00 local, G00 of the router 1. The platform of it is S, switch. What model? 2960. To what interface of switch router 1 is connected? Fast Ethernet 01. There is another device called R2 that is neighbor to R1. It is connected to serial 000 of the route 1 on the local. The capacity of it or platform is R router. What model? 2900 series. Which company? Cisco. It is and router 1 is connected to serial 001 of the router 2. See if the topology verifies that the router 1 is connected to S1 G002F0 mode. Router 1 is connected to router 2 from its serial 000 to serial 001 of the router 2. Let's go back to command line interface of router 1 and perform more show commands related to CDP. Another one is show CDP neighbors detailed. This one will output detailed information about neighboring devices, including their IPv4 addresses. Show CDP neighbors detail. S1 is a neighboring device to R1. S1 has this IPv4 address assigned to its VLAN 1, and router 1's G00 is connected to fast Ethernet 0 of S1. And then another device is a neighboring device called R2. Its IP address is its IPv4 address is 209.1.1.2. Serial 000 of the router 1 is connected to serial 001 of the router 2. Another similar command is show CDP entry asterisk. This also provides or outputs the same information that we saw on the details. The platform, neighboring device name, and IP address of it. And it's a good idea for you to execute both commands and compare them in details to see if in what areas they are similar, what areas they are different. Sometimes you need to clear the CDP of your router, because if you don't and you do not disable CDP, later on you want to use CDP, it may remember information from past that throws you off. In order to clear the CDP table, the command is clear CDP table. That's it, it clears it. So if I perform show CDP, right now CDP is enabled, but it is not going to remember any information from the past. If you change the devices that are attached, it may remember one of those devices that you detached from it. So clear CDP table is going to get rid of that extra information that you don't want to see. So this is a powerful tool for troubleshooting, but turn it off after you complete the troubleshooting, because of the information that is exchanged between the neighboring devices may be captured by a third party and use it against your system. So it could pose a security threat. CDP is for Cisco devices. It's a Cisco proprietary type of protocol. IEEE has a version of it that is non-proprietary, but works very similar to CDP. CDP does not provide information for IPv6, although if you go to Cisco site or some internet sites, they claim they do, but as you can see, it didn't provide any information about IPv6 addressing of the neighboring devices. It's because IPv6 is not using ICMP, it's using ICMPv6, it's not broadcast based. So for IPv6 devices, the command is show IPv6 neighbors. You can do many other show commands after, you can use many other switches after IPv6, but the one that we want for this particular exercise is show IPv6 neighbors. It's sort of the same as what you call it, CDP. There is none being displayed because no exchange of information we have had. So let's go ahead and ping somebody from PC3 using IPv6. We go to command prompted and we ping the server that is in the remote network with the IPv6 of 2001 db2 double colon 2 ping 2001 colon db2 double colon 2, and let's wait for the replies to come back. The 4 echoes are going to be sent. We expect the 4 echoes back. Request timeout for a couple of them. I made a mistake in typing the IPv6 address, not 2011. 2001. That was the reason, so let me correct that one. Replies are coming back. Now let's go ahead and see if show IPv6 neighbors is going to reveal any information on the router. Yes, it provides the neighboring device to router 1 to be to have IPv6 address of 2001 colon db1 double colon 3, which is the IPv6 address of the PC3, and it is connected to G00 of the router 1. So CDP is being used mainly for IPv4, and since there's a different method, neighbor discovery protocol is being used for IPv6, show IPv6 neighbors is the command to reveal sort of the same information as CDP does for IPv4 addressing. So that's how CDP works for neighbor discovery. For this section, I have purposely put some wrong configuration in the internet network in order to show you how to troubleshoot. Let's go to PC3's command line interface and see if we can ping PC5 or server 2. So we'll go to command line interface of the command prompt of the PC3, and we want to ping PC5. They tell us PC5 has the IPv4 address of 192.168.1.5. So I'm going to go ahead and ping that. Ping 192.168.1.5. See if any replies coming back. If everything's working, I should receive replies back from that IPv4 address. But if I keep on receiving request timed out, I say that, okay, it's the first ping, let me try it one more time. If for the second time I receive all those request timeout, then there is something wrong. I'm trying the pinging of PC5 one more time, and no reply is coming back. Since PC3 and PC5 are in the same network, they should have the same network addresses. So let me go ahead and see if I can ping that PC using its IPv6 address. Ping 2001 colon db1 double colon 5. Oh, replies are coming back. Therefore, it tells me that network cabling, there is no issue with network cabling. The IPv6 works, IPv4 is not working. So let me examine the IP addressing scheme of PC3 first. What command? IP config /all to see what type of IPv4 addresses I have on this PC. This PC is configured with 192.168.1.3 and its default gateway is 192.168.1.2.5. The subnet mask of it is 255.255.255.0. Therefore, I expect PC5 to have an IP address with exactly the same 3 octets, 192.168.1. So let me go ahead and physically walk towards PC5 and examine its IPv4 address. 192.168.2, that's a different network, so I need to change that. I change that, and then I'm going to, from this PC, ping PC3, ping 192.168.1.3, see if replies are coming back. That was it. The problem was the wrong network address on PC5. So we have corrected that. Let's see if we can reach a remote network from PC3. So I go to the command prompt of PC3 and ping the server which has the IPv4 address of 192.168.2.2. Destination host unreachable. Whenever you receive that one, the problem is related to routing. Let me see if I can ping that server using its IPv6 address. Ping 2001 colon db2 :2. If replies comes back, there is no cabling issue. The problem is definitely the routing on IPv4 network. Replies are coming back. Therefore, the problem is routing. I've already checked the IP address of IPv4 address of PC3 and its default gateway are configured correctly. In order to double check on that one, I go to router 1 and perform from privilege mode, perform show IP interface brief to see if the G00 of router 1 has the same IPv4 address that I configured as default gateway for PC3. Yes, it has. Then I'm going to examine its routing table, its IPv4 routing table. Show IP route. There is a connected network to G00. There is another connected network to serial 00. They seem to have the correct network address and correct IP addresses, and is the IP address of the G00, the first and the second one, exact IP address, IPv4 address of serial 000. Now, can you guess what the problem seems to be? This router only has 2 routes for 2 connected networks to it. Therefore, it doesn't, it's not capable of reaching any network that is not attached to it. We need to fix that part. So I go to global configuration mode and create a default route to reach any network with any subnet mask. The packets for that destination network should go out of serial 00 of the router 1, and then I perform the same show command, show IP route, to see the difference and compare it with the previous output. Notice an extra command, an extra route is added into the routing table of the router 1 for IPv4 addressing, and it is S*, meaning default static. Let's now go ahead and see if we can ping the server from PC 3, using the IPv4 address of the server in the remote location. If we have configured the static route correctly, replies should come back. As you can see, replies are coming back, and we fixed that problem as well. Normally, if you cannot reach a remote network, first check to see if you can reach a host within your network. Then check to see if you can ping the default gateway that you are configured with, and then move on to the next network. For example, ping serial 000's IPv4 address, and then IPv4 address of serial 001. If you cannot ping that one, definitely you have routing issue, and routing must be configured. These are some simple steps that you can take to test or troubleshoot. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.